Our question addresses how the length of the hanging string will affect the rotational speed of the flying pig. The string's length is being varied, and this change in length affects how fast the hanging pig takes for one revolution motion. The rotational speed of an object rotating around an axis is the number of turns of the object divided by time. The equation for rotational speed is W equals V over R, in that V equals 2 pi times R divided by T. So W equals 2 pi divided by T. This experiment will explain how the string length indirectly affects the rotational speed of the flying pig. Our claim is that the longer the string is, the more time the flying pig will take to do one rotation, which will make the rotational speed smaller.
The independent variable in this lab is the length of the string that is attached onto the pig. The dependent variable is the rotational speed of the hanging pig. The string length will affect the amount of time the hanging pig will take to complete one rotation, and this time affects the rotational speed. Using tracker, the rotational speed can be obtained. The procedure is as follows. Step 1. Have batteries inserted in the pig. Step 2. Attach the pig with a string that has a length of 83 centimeters. Step 3. Attach the end of the string to the ceiling. Step 4. Toss the pig around so it moves in a circular motion. Step 5. Have a recording device on the ground below the center of the pig's circular motion. Step 6. Have the recording device look up where it can see the pig's movement. Step 7. Start the recording device and stop when the pig completes 3 rotations. Step 8. Use tracker to track the movement of the pig and create the time versus angular velocity graph. Step 9. Repeat step 2 to 8 using a 42 centimeter string.
In conclusion, the data supports our claim, which states that the longer the string, the smaller the angular velocity. For the first graph, with a string length of 42 centimeters, the red/green line shows the data that we acquired, and the black line shows the line of fit. The line of fit has a constant value of 4.8 radians per second, which is larger than the line of fit, the pink line, for the second graph, which has an almost constant value of 3.35 radians per second. This data supports our claim because the longer the string, the larger the angular velocity was. We found a theoretical value by dividing the number of rotations by the time it took to complete those rotations, and we used the equation W is equal to change in theta over change in time to find the theoretical angular velocity. Some problems that we faced during the lab include human error while timing the rotations per second while finding theoretical values, and this was solved by taking the time for multiple rotations and dividing by the time it took to complete those rotations to get more accurate data. And another problem we faced was the tracker program not tracking the pig's flight properly, and this was solved by using a smaller, brighter target that is easier to follow in the dark. Some ideas for future investigations would include how the rotational speed is affected by the mass of the object, how to find the tension in the string, and how to maximize the rotational speed.